November 7, 1944. 23,000 feet above the rolling farmland of eastern Germany, Oberleutnant Franz Stigler felt the first tremor of doubt ripple through his confident hands on the control stick of his Messerschmitt Bf 109 Gustav 6. The morning sun slanted through his canopy, illuminating the frost crystals forming at the edges of the plexiglass. His radio crackled with the familiar voices of his squadron mates, veterans like himself who had survived 3 years of aerial combat over Russia, France, and now the shrinking borders of the Reich itself. Then he saw them. 4 silver shapes, impossibly high, impossibly fast, cutting contrails across the pale winter sky at an altitude his aircraft could barely maintain. P-51 Mustangs, American fighters that shouldn't have been there, couldn't have been there according to every briefing he'd received about enemy capabilities and fuel range. Yet there they were, cruising with an ease that made his own straining, fuel-starved fighter feel like an obsolete relic. Stigler pushed his throttle forward, feeling the Daimler-Benz DB605 engine respond with everything it had. His airspeed indicator climbed past 370 miles per hour, approaching the fighter's maximum level speed of 386 miles per hour at this altitude. The Americans didn't alter course. They didn't need to. Within minutes, the silver Mustangs had simply pulled away, maintaining what appeared to be a comfortable cruising speed while Stigler's engine screamed at maximum continuous power, consuming his precious fuel reserves at an unsustainable rate. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. He watched them disappear into the western sky, heading back toward England with fuel to spare, and in that moment, Franz Stigler understood something that German High Command had not yet officially acknowledged. The Luftwaffe no longer controlled the air over its own homeland. The realization wasn't born from a dramatic dogfight or a desperate escape. It came from something far more devastating, the simple, undeniable recognition that American fighters could outrun, outclimb, and outlast the best aircraft Germany could field. They weren't just winning through numbers. They possessed technical superiority so profound that courage, skill, and experience had become insufficient. This was not how it was supposed to be. The Luftwaffe had pioneered modern aerial warfare, had refined fighter tactics in Spain, had dominated the skies over Poland and France, with aircraft designed by the world's finest aeronautical engineers. Willy Messerschmitt's fighters had set world speed records before the war. Kurt Tank's Focke-Wulf 190 had been called the finest fighter in the world when it entered service in 1941. German pilots trained extensively, many with combat experience dating back to 1936 in Spain. They understood their aircraft intimately, could coax maximum performance from every control surface and every horsepower their engines produced. Yet by late 1944, Luftwaffe pilots across every front were reporting the same disturbing pattern. American P-51 Mustangs appeared at will, operated at altitudes German fighters struggled to reach, maintained speeds German aircraft couldn't match in level flight, and possessed fuel reserves that allowed them to escort bomber formations deep into German territory and still engage in extended combat. The mathematics of aerial warfare had shifted, and German pilots found themselves on the wrong side of an equation they couldn't solve through skill alone. The sky, once Germany's domain, had become someone else's hunting ground. The German fighter pilot who climbed into his cockpit in late 1944 carried with him a legacy of innovation and dominance that stretched back nearly a decade. The Luftwaffe had not simply appeared at the war's beginning. It had been carefully constructed in defiance of Versailles Treaty restrictions, developed in secret training facilities in the Soviet Union during the 1920s, and refined through combat experience in Spain's Civil War beginning in 1936. By 1939, Germany possessed what many military analysts considered the world's most advanced air force. The Messerschmitt Bf 109, designed by Willy Messerschmitt and first flown in 1935, incorporated features that set new standards for fighter design. It featured an all-metal monocoque construction, retractable landing gear, an enclosed cockpit, and a fuel-injected inverted V12 engine that could maintain power delivery during negative G maneuvers that would starve carbureted engines of fuel. In 1939, a specially modified Bf-109 set a world speed record of 469.22 miles per hour, a performance that shocked aviation experts worldwide. The tactics employed by Luftwaffe pilots were equally revolutionary. During the Spanish Civil War, German volunteers under the command of Wolfram von Richthofen, cousin of the famous Red Baron, developed the Schwarm formation, a flexible fighting unit of 4 aircraft divided into 2 pairs. This replaced the rigid 3-aircraft Vic formations used by other air forces and provided tactical advantages that British and American pilots would later adopt as their own. German pilots learned to exploit their aircraft's superior diving speed and roll rate, attacking from altitude, making a single high-speed pass, then using superior dive performance to escape before enemies could respond. The early war years validated German confidence. Over Poland in September 1939, Luftwaffe fighters achieved complete air superiority within days. Over France in May and June 1940, German fighters decimated French air opposition and inflicted severe losses on British units attempting to support ground forces. During the Battle of Britain in summer 1940, despite ultimate strategic failure, German pilots demonstrated tactical proficiency and aircraft performance that deeply concerned British commanders. The Spitfire could match the Bf-109 in most performance parameters, but German tactical formations and pilot experience provided significant advantages. By 1941, the Focke-Wulf Fufwa 190 entered service, providing Luftwaffe units with a fighter that many pilots considered superior to the Bf-109. Designed by Kurt Tank, the Fo 190 featured a powerful BMW radial engine, producing 1,700 horsepower, exceptional roll rate, in heavy armament including 4 20mm cannons and 2 machine guns, and rugged construction that could absorb significant battle damage. British pilots encountering the Fufw 190 in late 1941 reported it as faster, better armed, and more maneuverable than any German fighter they'd previously faced. For a period, the Felved 190 achieved a kill ratio advantage over Royal Air Force fighters that alarmed British command. German fighter pilots of this era trained extensively, typically receiving 200 to 250 hours of flight instruction before assignment to operational units. They studied aircraft recognition, practiced formation flying, learned gunnery against towed targets, and received tactical instruction from combat veterans. Many pilots posted to operational squadrons in 1940 and 1941 possessed technical understanding of their aircraft that matched or exceeded ground crew knowledge. They could diagnose engine problems by sound, compensate for equipment failures through improvisation, and extract maximum performance through intimate familiarity with every system. The ideology supporting this confidence was not mere propaganda. German aeronautical engineering was genuinely world-class. Messerschmitt, Focke-Wulf, Heinkel, and other manufacturers employed brilliant designers who understood advanced aerodynamics, structural engineering, and propulsion systems. German engines, particularly the Daimler-Benz inline designs and BMW radials, represented cutting-edge technology. German aviation fuel, using synthetic production methods developed through coal liquefaction, provided high-octane performance that supported high compression ratios and supercharger boost pressures. The Luftwaffe's training doctrine emphasized quality over quantity, producing pilots who understood not just how to fly, but why aircraft behaved as they did. This created a cadre of airmen who could adapt to changing tactical situations, who understood the physics of aerial combat, and who could push their aircraft to performance limits with confidence born from technical comprehension rather than reckless courage. German fighter doctrine in 1944 remained rooted in principles established during earlier successful campaigns, but the operational reality had shifted in ways that doctrine could not accommodate. Luftwaffe fighter wings, called Jagdgeschwader, operated under tactical frameworks that emphasized offensive action, aggressive engagement, and exploitation of aircraft performance advantages. Pilots were trained to seek advantageous positions, attack decisively, and disengage before enemy numerical superiority could be brought to bear. The standard German fighter in late 1944, the Bf-109 Gustav VI, represented the culmination of continuous development of Messerschmitt's basic design. It mounted a 30mm cannon firing through the propeller hub, supplemented by two 13mm machine guns mounted above the engine. The Daimler-Benz DB605A engine produced 1,475 horsepower, using MW50 methanol water injection for emergency boost. Maximum speed reached 386 miles per hour at 19,685 feet altitude. Rate of climb exceeded 3,937 feet per minute at sea level. The aircraft could reach 39,370 feet altitude, though performance degraded significantly above 25,000 feet. These specifications appeared competitive on paper. The Gustav VI could outclimb most Allied fighters at low altitude. Its armament could destroy bombers with brief firing bursts. Its fuel injection system allowed inverted flight and negative G maneuvers without engine cutout, providing tactical flexibility denied to carbureted opponents. German pilots understood these advantages and attempted to exploit them through tactical discipline and aggressive action. However, the operational environment of late 1944 imposed constraints that transformed technical specifications into insufficient capabilities. American bomber formations operated at altitudes between 22,000 and 28,000 feet, requiring German fighters to climb to interception altitude, engage heavily defended formations, and fight through increasingly numerous American escort fighters. The Gustav VI's climb performance, excellent at low altitude, degraded significantly above 20,000 feet, where thinner air reduced engine power and propeller efficiency. Fuel capacity became the critical limitation. The Bf 109 Gustav VI carried 88 imperial gallons of fuel internally, providing approximately 1 hour of flight time at combat power settings. A drop tank could extend range, but had to be jettisoned before combat, reducing effective combat radius. Pilots intercepting bomber formations over central Germany faced a brutal calculation: climb to altitude, consuming fuel, engage bombers while American escorts dove. From superior altitude with speed advantage, fight while monitoring fuel state, then break off and return to base before fuel exhaustion. The Americans faced no equivalent constraint. P-51 Mustangs escorting bomber formations to targets deep in Germany carried fuel reserves that allowed extended combat at high altitude, pursuit of fleeing German fighters, strafing attacks on ground targets, and return to England with comfortable margins. German pilots couldn't understand how American fighters maintained presence over German territory for hours, while their own aircraft struggled to remain airborne for sustained operations. The psychological impact of this disparity manifested gradually through accumulated encounters. A German pilot scrambling to intercept bombers over Munich knew he possessed perhaps 20 minutes of combat time before fuel concerns forced disengagement. An American pilot escorting those same bombers operated with fuel reserves measured in hours could accept combat at any altitude, could pursue opponents through extended maneuvers, and could afford aggressive tactics that German pilots, constantly monitoring fuel gauges, could not match. German tactical doctrine assumed the ability to choose engagement and disengagement moments. It presumed German fighters could attack, then use superior diving speed or climb rate to escape, before numerical disadvantage became decisive. These assumptions worked when German fighters engaged opponents with comparable fuel constraints and performance limitations. Against P-51 Mustangs with surplus fuel, altitude advantage, and superior high-altitude speed, the tactical framework collapsed. German pilots found themselves forced into defensive combat, unable to dictate engagement terms, unable to escape pursuers through speed or climb, reduced to desperate maneuvers that consumed fuel they couldn't afford to waste. The P-51 Mustang that haunted German skies in late 1944 represented not a single brilliant innovation, but rather the convergence of multiple technical advantages into an integrated weapons system that exceeded the sum of its parts. North American Aviation designed the Mustang originally for the British Purchasing Commission in 1940, completing the prototype in just 117 days. The early Allison engine variants showed promise but suffered from poor high-altitude performance that limited their effectiveness as escort fighters. The transformation came when British engineers married the Mustang airframe to the Rolls-Royce Merlin engine, creating the P-51B variant that entered service in late 1943. American production used Packard-built Merlins designated V1650, producing 1,490 horsepower at 21,000 feet and 1,720 horsepower with war emergency power. This combination yielded a fighter with maximum speed of 440 miles per hour at 25,000 feet, precisely the altitude where American bomber formations operated and where German fighters struggled with degraded engine performance. The Mustang's critical advantage, however, lay not in maximum speed but in fuel capacity and aerodynamic efficiency. The P-51D, which became the standard escort fighter variant, carried 184 gallons of fuel internally in 6 self-sealing tanks. 2 85-gallon drop tanks extended total fuel capacity to 354 gallons, providing combat radius exceeding 850 miles. This meant a Mustang could fly from England to Berlin, engage in combat for 20 to 30 minutes, and return with fuel reserves remaining. No German fighter possessed comparable endurance. The aerodynamic efficiency of the Mustang's laminar flow wing design, developed by North American's chief engineer Edgar Schmude, reduced drag by approximately 20% compared to conventional airfoils. This allowed the aircraft to cruise at 362 miles per hour while consuming only 80 gallons per hour at 25,000 feet, compared to the Bf-109 Gustav VI, which consumed approximately 70 gallons per hour at combat cruise settings, but carried less than half the Mustang's fuel load. German pilots encountering Mustangs at operational altitudes faced opponents operating within optimal performance envelopes, while their own aircraft struggled at the edge of useful capability. At 25,000 feet, the Gustav VI's maximum speed of 372 miles per hour barely exceeded the Mustang's economical cruise speed. The Focke-Wulf 190 Anton, powered by the BMW 801 radial producing 1,700 horsepower, performed even worse at altitude, with maximum speed dropping to 357 miles per hour at 20,000 feet and degrading further as altitude increased. Luftwaffe test pilots who examined captured P-51 Mustangs wrote reports that circulated through fighter units, describing capabilities that frontline pilots already knew from bitter experience. The reports noted the Mustang's exceptional visibility from the bubble canopy, superior to the limited rear visibility of German fighters. They documented the aircraft's harmony of controls, light stick forces that allowed precise maneuvering at high speeds, where German fighters became increasingly stiff and unresponsive. They measured the Mustang's roll rate, superior to both the Bf-109 and FW-190, at speeds above 300 miles per hour. Most critically, German test pilots confirmed what operational pilots reported. The Mustang could maintain combat power settings for extended periods without overheating, could cruise at high speeds without excessive fuel consumption, and could operate effectively at altitudes where German fighters lost performance advantages. A Luftwaffe technical report from December 1944 concluded that the P-51D represented the most balanced fighter aircraft in operational service, possessing no single overwhelming advantage, but rather a combination of capabilities that made it superior to German fighters in the escort role. The industrial context amplified these technical disparities. North American Aviation's Inglewood, California plant produced Mustangs at rates exceeding 1 per day by mid-1944. Peak production reached 15 aircraft per day in early 1945. Total P-51 production exceeded 15,000 aircraft between 1940 and 1945. Germany produced approximately 35,000 Bf-109 aircraft of all variants during the entire war, but chronic shortages of aluminum, fuel, and skilled labor meant operational strength never matched production numbers. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. American pilots flying Mustangs received aircraft with functioning equipment, reliable radios, gun sights that worked, and engines that performed to specification. German pilots increasingly flew aircraft assembled by forced labor, using substitute materials, with equipment that malfunctioned or was simply omitted due to parts shortages. The technical specifications in the manual described capabilities the actual aircraft could no longer deliver. Hauptmann Heinz Nock, a Luftwaffe ace with 33 confirmed victories by late 1944, documented his encounters with American fighters in a diary that survived the war. His entries from autumn 1944 record the psychological progression from confidence to recognition of technical inferiority. On September 27, 1944, Nock led his Staffel, intercepting a bomber formation near Kassel. His diary entry described the engagement with clinical precision that couldn't mask underlying frustration. Attacked formation at 24,000 feet, closed to 400 meters when escorts engaged from above. P-51s. Dove away using emergency power, reaching 600 kilometers per hour indicated. Looked back, expecting to have outdistanced them. Americans were still closing. Pulled into climbing turn, engine protesting at maximum boost. Americans followed effortlessly, one firing from 500 meters. Hits on my port wing, rolled inverted split S to deck. Lost them in ground haze near Göttingen. Fuel state critical. Landed at Vector with less than 50 liters remaining. Checked aircraft, 13 hits, 2 in elevator. 3 of my pilots missing. Similar accounts appeared in squadron records across the Jagdwaffe. Oberleutnant Walter Krupinski, flying with Jagdgeschwader 52 on the Eastern Front before transfer west in autumn 1944, recalled his first combat against American escorts with visceral clarity in post-war interviews. "We thought we knew air combat. 3 years fighting Russians taught us everything about dogfighting. Then we met the Americans over Germany. Different war entirely. They didn't dogfight. They dove from 6,000 meters altitude with such speed we couldn't turn into them. 1 pass, maybe 2. Then they were gone before we could respond. When we tried to pursue, they simply cruised away. Our engines screaming at maximum power, their aircraft just cruising, as if they had fuel to burn, and we were already running on fumes." The pattern repeated across every front where Luftwaffe fighters engaged American escorts. Major Gerhard Barkhorn, the second highest scoring fighter ace in history with 301 victories, predominantly achieved against Soviet aircraft, found his tactical expertise insufficient against American technology. In November 1944, Barkhorn led Jagdgeschwader 6 against bomber formations attacking synthetic oil plants. Despite his immense experience and exceptional piloting skill, Barkhorn's after-action reports documented consistent pattern. German formations climbing to intercept altitude, American escorts engaging with altitude and speed advantage, German pilots forced into defensive combat while monitoring fuel consumption, disengagement becoming necessary before effective attacks on bombers could be pressed home. The Luftwaffe attempted tactical adjustments. Fighter units adopted Sturmgruppe tactics, concentrating heavily armed and armored full 190 variants into tight formations designed to break through escorts and destroy bombers through concentrated firepower. The Sturmgruppe aircraft carried additional armor plating and heavier cannon armament, sacrificing speed and maneuverability for destructive capability and survivability against bomber defensive fire. Lighter Bf 109 units provided top cover, engaging escorts while Sturmgruppe aircraft attacked bombers. The tactics achieved limited success, but couldn't overcome fundamental performance disparities. Sturmgruppe formations, already slow due to armor and heavy armament, became easy targets for Mustangs diving from altitude with decisive speed advantage. The covering Bf 109 units found themselves outnumbered, outrun, and unable to prevent American fighters from decimating the heavily laden Sturmgruppe aircraft. On March 24, 1945, Sturmgruppe tactics collapsed entirely when American fighters destroyed more than 40 German aircraft in a single engagement near Hamburg, killing or wounding most of the experienced pilots the Luftwaffe could no longer replace. Individual skill and tactical innovation couldn't compensate for technical inferiority, backed by industrial abundance. German pilots grew increasingly demoralized as they recognized the mathematical inevitability of their situation. Each mission consumed irreplaceable fuel. Each combat risked irreplaceable experienced pilots. Each loss reduced operational strength that couldn't be restored through production or training pipelines that had broken under sustained Allied bombing and resource shortages. Major Heinz Baer, a veteran with 220 victories and one of the Luftwaffe's most aggressive fighter leaders, summarized the situation in a November 1944 conference with Luftwaffe command staff. His comments, recorded in meeting minutes discovered post-war, captured the reality frontline pilots faced. We cannot win air superiority through pilot skill when the enemy possesses unlimited fuel, superior high-altitude performance, and numerical advantage. Our fighters struggle to reach combat altitude. Their fighters cruise there with fuel to spare. Our tactics assume ability to dictate engagement terms. They dictate terms through technical superiority. We need better aircraft, or we need to stop pretending we can defend German airspace. The psychological collapse of Luftwaffe fighter confidence reached its apex during Operation Bodenplatte on January 1, 1945. Luftwaffe Command planned a massive surprise attack on Allied airfields in Belgium, Netherlands and France, intending to destroy Allied tactical air power on the ground and regain temporary air superiority. Nearly 900 German fighters launched in the pre-dawn darkness, representing virtually every operational aircraft the Luftwaffe could assemble. The planning assumed Allied forces would be unprepared on New Year's morning, allowing German fighters to strafe parked aircraft and installations with minimal opposition. The operation achieved tactical surprise, destroying or damaging approximately 465 Allied aircraft, primarily on the ground. However, the cost devastated the Luftwaffe beyond recovery. German forces lost 271 aircraft, with 214 pilots killed or captured, including experienced formation leaders, instructors, and squadron commanders the Luftwaffe could not replace. The losses represented nearly 30% of participating forces, an attrition rate that would have been considered catastrophic even if the operation had achieved strategic objectives. More significantly, Allied forces replaced their aircraft losses within weeks through industrial production and logistics pipelines that operated with mechanical efficiency. American factories produced fighters faster than combat could destroy them. New aircraft arrived in England within days of losses, flown by replacement pilots trained in numbers that dwarfed German training capacity. The Luftwaffe's aircraft and pilot losses were permanent, irreplaceable, final. Oberleutnant Franz Stigler, the pilot who had watched Mustangs pull away from his straining Gustav VI in November, participated in Bodenplatte, attacking the Allied airfield at Eindhoven. His post-mission report described successful strafing runs that destroyed several parked aircraft, followed by his own fighter being damaged by Allied anti-aircraft fire during egress. He landed at an emergency field with a damaged engine and multiple holes in his airframe. The report concluded with an observation that reflected growing consensus among surviving pilots. "We destroyed their aircraft today. They will have replacements tomorrow. We lost irreplaceable pilots and aircraft we cannot replace. This is not sustainable." German fighter pilots returning from Bodenplatte missions encountered a landscape that reinforced their technological pessimism. Many found their home airfields had been bombed during the operation, destroying fuel stocks, spare parts, and ground equipment. The fuel consumed by 900 fighters in the Bodenplatte operation represented a significant portion of Germany's remaining aviation gasoline reserves. The synthetic oil plants producing that fuel had been systematically destroyed by the very bomber. Formations German fighters could no longer effectively intercept due to American escort fighters. The mathematical reality became inescapable. Germany's monthly fighter production, approximately 1,000 aircraft in January 1945, couldn't replace operational losses. Pilot training had been reduced to less than 100 flying hours due to fuel shortages, compared to 300 hours American pilots received. New Luftwaffe pilots arriving at operational units possessed theoretical knowledge but lacked practical skills to survive combat against experienced American pilots flying superior aircraft. Major Günther Rahl, third highest scoring ace with 275 victories, predominantly on the Eastern Front, transferred to command duties in late 1944 after his experience made him too valuable to risk in combat. In conferences with Luftwaffe staff, Rahl presented analysis that quantified the crisis. German fighters required full internal fuel plus drop tanks to intercept bombers over central Germany. Combat consumed approximately 30% of fuel reserves. Return to base required 40% of original fuel load. This left 30% for actual combat, approximately 15 to 20 minutes at combat power settings. American escorts operated with surplus fuel, allowing extended combat. The mathematics guaranteed defeat regardless of pilot skill or tactical sophistication. The introduction of the Messerschmitt Me-262 jet fighter in autumn 1944 briefly suggested technological parity might be achievable. The Me-262 possessed maximum speed of 540 miles per hour, dramatically faster than any Allied piston-engine fighter. However, chronic fuel shortages, limited production numbers, short engine life requiring complete replacement after 10 to 12 hours of operation, and vulnerable acceleration characteristics made the jet fighter tactically interesting but strategically irrelevant. Fewer than 200 Me-262s became operational before war's end, and many were destroyed on the ground by Allied strafing attacks before they could engage in combat. By February 1945, Luftwaffe fighter operations had effectively ceased meaningful resistance to Allied bomber formations. American raids penetrated German airspace with minimal losses. Escort fighters roamed freely, strafing ground targets, attacking transportation networks, and destroying the remaining infrastructure of German fighter operations. German pilots, when they could obtain fuel to fly missions, understood they were participating in futile gestures rather than effective defense. The sky had become American property, controlled not through superior courage or tactics, but through technical advantages backed by industrial capacity that German forces could observe but could not counter. The Luftwaffe's fighter pilots, among the most skilled and experienced aerial combat veterans in history, had been rendered obsolete by technology they couldn't match and fuel they didn't have. The realization was complete, undeniable, and psychologically devastating. Franz Stigler survived the war, but the psychological scars of technical inferiority marked him as deeply as any physical wound. In March 1945, with fuel allocations reduced to levels that made training flights impossible and combat sorties suicidal, Stigler's unit received orders to defend against American bomber formations using whatever aircraft remained operational. He flew his last combat mission on April 17, 1945, intercepting B-17 bombers near Munich. The mission report, preserved in fragmentary Luftwaffe records, documented an encounter that lasted less than 10 minutes before fuel concerns forced disengagement without achieving any bomber kills. Stigler landed at his base to find it under attack by American P-47 Thunderbolts, strafing parked aircraft and ground installations. He abandoned his aircraft and took cover in a drainage ditch, while American fighters methodically destroyed the remaining Bf-109s of his squadron. When the attack ended, Stigler walked among the burning wreckage of aircraft. His mechanics had struggled for weeks to keep operational, despite parts shortages, substitute materials, and degraded maintenance equipment. He later told American interrogators that watching those aircraft burn felt like witnessing the cremation of a belief system. The Luftwaffe had been built on premises of technical excellence and tactical superiority. Both had proven insufficient against enemies who possessed better technology and unlimited resources. The broader statistics confirmed what individual pilots experienced. Between January and May 1945, the Luftwaffe lost approximately 2,000 fighters in combat, while American bomber formations suffered their lowest loss rates of the war. The 8th Air Force, conducting daylight strategic bombing from England, reported loss rates below 1% by April 1945, compared to loss rates exceeding 10% during unescorted raids in 1943. The transformation wasn't attributable to reduced German resistance, but rather to overwhelming American technical and numerical superiority that made effective German resistance impossible. German pilots who survived to witness surrender in May 1945 carried knowledge that shaped their post-war lives. Major Heinz Baer, who had argued for realistic assessment of German fighter capabilities in late 1944, survived the war with 220 victories and became a test pilot for American aircraft manufacturers in the post-war years. His technical reports on captured German aircraft, written for American intelligence, displayed none of the defensive nationalism that characterized some German accounts. Instead, Baer catalogued German aircraft deficiencies with clinical precision, acknowledging that technical inferiority, not pilot quality, had determined outcomes. Günter Rahl, who survived the war as Germany's third highest-scoring ace, later served in the post-war West German Air Force and became a senior NATO military officer. In interviews conducted during the 1960s and 70s, Rahl consistently emphasized that German defeat in the air war resulted from industrial and technical disparities rather than tactical failures. He described watching American bomber formations in early 1945, escorted by what seemed like limitless numbers of fighters, while German units struggled to assemble even squadron-strength formations due to fuel shortages and aircraft losses. The memory remained vivid decades later, the image of American abundance contrasted against German scarcity. Walter Krupinski, the Eastern Front veteran who had been shocked by American capabilities when transferred west, also survived and later served in the post-war Luftwaffe. His memoirs, published in the 1980s, devoted extensive sections to analyzing why German fighters failed against American escorts. Krupinski's conclusions centered on fuel capacity and high-altitude performance, the technical factors that allowed American fighters to dictate engagement terms. He wrote that German pilots possessed skill and courage in abundance, but these qualities couldn't overcome aircraft that simply couldn't compete with American technology at operational altitudes. The psychological impact on surviving Luftwaffe personnel extended beyond individual pilots. Ground crews, mechanics, and support staff, who had maintained German fighters throughout the war, understood the deteriorating situation perhaps more clearly than pilots. They worked with substitute materials, improvised repairs, and struggled to maintain aircraft that were literally falling apart from metal fatigue, combat damage, and inadequate maintenance. By war's end, mechanics told interrogators they felt they were maintaining flying coffins rather than combat aircraft, sending pilots into battle in machines that couldn't protect them against superior opponents. Part 8. The Industrial Autopsy. The full scope of American industrial superiority became apparent to German aviation personnel only after surrender, when they witnessed American logistics operations firsthand and examined production facilities they had never imagined existed. Luftwaffe officers brought to England and later to the United States for technical interrogations found themselves confronted with evidence that explained every defeat they had experienced but had not fully comprehended during combat operations. Colonel Johannes Steinhoff, a highly decorated fighter ace with 176 victories who survived severe burns after a takeoff accident in April 1945, later described touring an American aircraft production facility in 1946. The visit shattered his remaining illusions about comparative industrial capacity. He watched B-29 Superfortress bombers rolling off production lines at rates of one aircraft every 63 minutes, assembled from components manufactured across dozens of factories and delivered via logistics networks that operated with mechanical precision. Steinhoff calculated that the single facility he toured produced more aircraft tonnage in 1 month than all German aircraft factories combined, produced in the same period during 1944. The fuel situation proved equally devastating upon examination. Germany's synthetic fuel production, dependent on coal liquefaction plants that had been systematically destroyed by bombing, produced approximately 391,000 tons of aviation gasoline in 1944. American petroleum industry produced approximately 660,000 tons of aviation gasoline per month by mid-1944, nearly 20 times German annual production. This disparity explained why American fighters could afford to cruise at high speeds, while German fighters struggled with fuel conservation that limited combat effectiveness. American aviation gasoline quality compounded the advantage. Standard American 100-octane fuel allowed higher supercharger boost pressures and more aggressive power settings than German equivalents. American 150-octane fuel, introduced in late 1944, permitted war emergency power settings that increased engine output by 15 to 20% without mechanical failure. German synthetic fuels, produced through coal liquefaction processes that yielded inconsistent octane ratings, limited engine performance and reliability. Luftwaffe pilots couldn't exploit their engines' theoretical capabilities because fuel quality wouldn't support the necessary boost pressures. The aluminum supply differential illuminated another critical factor. American aluminum production exceeded 800,000 tons annually by 1944, supporting aircraft production across multiple manufacturers while providing material for other war industries. Germany's aluminum production, dependent on bauxite imports that became increasingly difficult to obtain as Allied forces captured territories and interdicted shipping, declined throughout the war. By 1944, German aircraft manufacturers struggled with aluminum shortages that forced use of substitute materials, including wood and steel, that increased weight and degraded performance. The magnificent German fighters described in pre-war specifications existed primarily on paper. Actual production aircraft incorporated compromises dictated by material shortages. German aviation engineers, examining American aircraft in detail after surrender, documented numerous technical features that German industry had attempted but failed to implement effectively. Self-sealing fuel tanks, standard on American aircraft from 1942 onward, used synthetic rubber compounds that German industry couldn't manufacture in sufficient quantities. American fuel tanks could absorb multiple bullet hits without catastrophic fire, while German tanks, using less effective sealing compounds or no sealing at all, ignited easily. Luftwaffe pilot casualties from fuel tank fires significantly exceeded American rates. American aircraft electrical systems operated at 24 volts, providing reliable power for radios, instruments, and gun sights. German aircraft used 12-volt systems that struggled to support equipment loads, particularly in cold weather operations where battery capacity degraded. German pilots frequently flew missions with inoperative radios or malfunctioning instruments due to electrical failures that American pilots rarely experienced. The cumulative effect of such technical differences, minor individually but significant collectively, created operational environments where American pilots fought with reliable equipment while German pilots improvised around chronic failures. Perhaps most significantly, American pilot training produced aviators with 300 to 400 hours of flight time before combat assignment, including extensive instrument flying, navigation, and gunnery training. German pilot training, constrained by fuel shortages that became critical in 1944, declined to under 100 hours. New Luftwaffe pilots arrived at operational units unable to fly in weather, unable to navigate precisely, and possessing minimal gunnery skills. They represented targets rather than threats to experienced American pilots flying superior aircraft. Post-war analysis conducted by the United States Strategic Bombing Survey, which included extensive interviews with German aviation industry leaders and Luftwaffe commanders, concluded that German aircraft production peaked in September 1944 at approximately 4,000 aircraft monthly, impressive given Germany's industrial constraints, but inadequate against American production that exceeded 8,000 military aircraft monthly during the same period. More critically, German production quality deteriorated throughout 1944 as skilled workers were conscripted for military service and replaced by forced labor that lacked expertise and motivation. Part 9. The Legacy of Technical Defeat. The lessons learned by Luftwaffe fighter pilots who survived to witness German defeat resonated far beyond individual experiences, shaping post-war military thinking and influencing the development of NATO air forces during the Cold War. The recognition that technical superiority, backed by industrial capacity, determined aerial warfare outcomes became foundational doctrine for Western military aviation development. The romantic notion of individual pilot skill overwhelming technical disadvantage died in the skies over Germany between 1943 and 1945, replaced by sober assessment that modern warfare demanded competitive technology supported by sustainable industrial production. Franz Stigler, the pilot whose November 1944 encounter with P-51 Mustangs opened this account, emigrated to Canada after the war and became a successful businessman. He maintained contact with the international fighter pilot community and eventually met Charles Brown, an American B-17 pilot whose damaged bomber Stigler had famously escorted to safety over Germany in December 1943 rather than shooting down. Their friendship, documented in numerous interviews and a published book decades later, allowed Stigler to process his wartime experiences through dialogue with former opponents, who respected his skill, while acknowledging the technical superiority that determined the air war's outcome. In conversations with Brown and other American veterans, Stigler consistently emphasized that German fighter pilots had not lacked courage, determination, or tactical proficiency. Rather, they had been defeated by aircraft that could fly higher, faster, and longer than anything Germany produced, supported by industrial infrastructure that replaced losses faster than combat inflicted them, and fueled by petroleum resources that allowed unlimited operations. The psychological burden of fighting with inferior equipment against superior opponents, Stigler explained, created a demoralization that tactical adjustments couldn't remedy. Knowing you cannot win, regardless of performance, affects combat effectiveness more profoundly than any physical limitation. The post-war German Air Force, established in 1956 as part of West Germany's NATO commitment, explicitly rejected the Luftwaffe's fighter doctrine in favor of approaches emphasizing technical parity and sustainable operations. German military aviation planners who had experienced wartime technical inferiority ensured their new air force would operate American-designed aircraft, including F-86, Sabres, and later 4 Phantoms, maintaining technical parity with potential opponents. The magnificent but impractical designs that had characterized late-war Luftwaffe projects, including the massive jet bombers and rocket interceptors that consumed resources without delivering operational capability, found no place in post-war doctrine that prioritized reliability and maintainability over theoretical performance. The experiences of Luftwaffe pilots influenced broader military thinking about technology and warfare. The recognition that superior equipment multiplies effective combat power, while inferior equipment negates skill advantages, became axiomatic in post-war military planning. NATO doctrine emphasized not merely matching Soviet capabilities, but maintaining decisive technical advantages that would allow smaller professional forces to defeat larger opponents. The lesson learned in pain by German fighter pilots, that quality without quantity means little, but quantity of superior quality means everything, shaped Cold War military investments and procurement decisions. For the individual pilots who survived, the memory of technical inferiority remained visceral decades after the war ended. Günter Rahl, interviewed in the 1990s shortly before his death, recalled watching American bomber formations in early 1945. Escorted by fighters, his units couldn't engage effectively due to fuel limitations and performance disadvantages. The frustration in his voice remained evident half a century later, as he described the helplessness of knowing enemy aircraft were destroying German cities, while Luftwaffe fighters lacked the fuel to intercept them or the performance combat escorts if they tried. "We were pilots without aircraft that could fight," Rahl said. "We had skill, courage, experience, all meaningless against opponents with better planes and unlimited fuel." The technical specifications that seemed competitive on paper, the Gustav 6's respectable maximum speed and impressive climb rate, proved insufficient against opponents operating in different performance envelopes. The Mustang's ability to cruise at speeds approaching German fighters' maximum velocities while carrying fuel measured in hours rather than minutes created tactical asymmetries that pilot skill couldn't overcome. German fighters struggled to reach combat altitude. American fighters cruised there comfortably. German fighters fought while monitoring fuel exhaustion. American fighters engaged with surplus reserves. The mathematics were inexorable. The story of Luftwaffe fighter pilots, recognizing their technical inferiority against American escorts, represents more than a narrow technical narrative about aircraft performance. It illuminates how technological change reshapes warfare, how industrial capacity determines strategic outcomes, and how even the most skilled professionals become ineffective when forced to fight with inadequate tools against better-equipped opponents. The ocean hadn't belonged to Japanese submariners because American sonar technology made stealth impossible. The sky didn't belong to German fighter pilots because American aircraft made effective defense impossible. Both lessons derived from the same fundamental reality. Modern warfare rewards technological superiority backed by industrial strength. Franz Stigler, watching those silver Mustangs pull away from his straining fighter in November 1944, understood a truth that took German high command months longer to acknowledge. The war was over, not because German pilots lacked courage or skill, but because American factories produced better aircraft faster than German industry could respond, fueled them with petroleum products German synthetic plants couldn't match, and supported them with logistics networks that never failed. The sky belonged to whoever controlled the technology to dominate it. By late 1944, that was no longer Germany. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.